appreciate the 10th International Conference of Climate Change. And it is our pleasure we can organize jointly organize with the Subras Mareta University and here in the Gifu. And thank you for joining the symposium. Thank you very much.
What was you dengar bahasa Inggris Jepang?
Thank you very much, Professor Koyama. Next, representing the Faculty of Applied Biological Sciences, Gifu University, it's my pleasure to introduce Professor Takahisa Nishizu, the Dean of the Faculty of Applied Biological Sciences. Professor Nishizu will share a few words on behalf of the faculty. Please join me in welcoming Professor Takahisa Nishizu to the stage.
Thank you so much. Good morning, everyone. Thank you for coming to Gifu University. My name is Nishizu, and I am the Dean of the Faculty of Applied Biological Sciences at Gifu University. All the faculty and staff would like to welcome all attendees. On behalf of the faculty, I would like to say a few words to welcome you to the International Conference on Climate Change. The hot and humid summers are very well known in Japan recently. In the last decade, the period of the summer season is gradually increasing. In Japan, it gets very hot from July to August, but it used to be rare for the temperature 35 centigrade degree or more in September. Recently, especially this year, there have been a lot of extremely hot days. The amount of hourly rainfall has also increased by 1.5 to 1.8 times over the past 10 years in Japan. Even in our daily lives, we are clearly beginning to feel climate change. And of course, the effects of this climate change on agriculture, forestry, and fisheries production are becoming apparent all over the world. I'm a food engineer, and for the past 10 years, I have been conducting research on the texture of senbei, a traditional Japanese rice cracker, in collaboration with a rice cracker manufacturer. The manufacturer, of course, takes into account the cost and blends various types and regions of the rice to produce good rice crackers. For this reason, the physical properties were always very stable. However, in recent years, due to the instability of the quality of rice, the usual blending has become difficult to maintain consistent qualities of rice crackers. It is our mission as agriculture scientists to contribute to the stable supply of agriculture, forestry, and fishery products. In order to maintain the production of agriculture, forestry, and fishery products under climate change, it is essential to reduce the causes of climate change related to agricultural production, to reduce the impact of climate change on agriculture, forestry, and fisheries, and to develop new agricultural methods to adapt to climate changes. If all attendees can deepen their discussions at this symposium, then this ICCC will be evaluated as a great success, I believe. I wish you all the best for the conference. Thank you very much.
Thank you very much, Professor Nishizu. Okay, now for the final remarks of our opening session, I'm pleased to introduce Professor Dr. Fitulia Rahamawati, Vice Rector of our co-host institution, Subras Mareta University, who is participating with us virtually. Let us give a warm welcome to Professor Fitria Rahmanati.
Good morning. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Vice President of Gifu University, Professor Hiroyuki Koyama, Dean of the United Graduate School of Agricultural Science, Dean of Applied Biology, the Honorable Distinguished keynote speakers, all of the committee, and all of the participants who are attending online or offline. Praise to Allah SWT for giving us time to attend this 10th International Conference on Climate Change, organized by Universitas 11 Maret in collaboration with the Graduate School of Agricultural Science, Gifu University. I apologize for not coming physically to this conference because we are now still in the internal consolidation, and it is important for us to stay in our office pribadi. I am deeply proud of UNS involvement in this event. This conference will be a vital platform for researchers, for scientists and scholars worldwide to come together and address one of the most pressing challenges of our time, which is the climate change. This year conference theme, Climate Change, Health and Plan, emphasize the intricate and critical relationship between environmental shift and the health of human population and plant ecosystem. As climate change intensifies, its effects on global health and agriculture become more pronounced. Rising temperature, extreme weather events, changing precipitation pattern, all directly influence food security, biodiversity, and public health. I believe that this conference will explore this interconnection, offering valuable insight and innovative approach to mitigate the impact and adapt to the challenge that we face. I'm optimistic that discussion and exchange held during this conference will contribute to the growing body of knowledge and, more importantly, inspire collaborative effort in addressing the climate change. This research presented in this conference will highlight current challenges and propose sustainable solutions that can be applied locally or globally. By bringing together experts from diverse fields, we can foster meaningful dialogue that bridge the gap between science, policy, and action. I thank the committee for their hard work in preparing this conference and all of the participants for their contribution. I wish you all a fruitful discussion and the initiation of some collaborative works. Thank you very much. Having a good day. Enjoy your conference. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Dr. Fitria Rahmanati. Okay, next we will begin our commemorative photo session. So for our virtual participants, we kindly ask you to stay standby. This session will only take a short time, and we appreciate your understanding. Thank you. Okay, we have, let's take photo with us. And then, so cameraman will take photo of us from the stage. So all participants have to move the this side. Please move. Thank you. Okay, each photographer, please in front the front. Difficult to take from all of them. Everyone, please move to the central part. Okay, student staff, I have to move the mic. 出してください。あれいらないんで。Are you ready? So let's move to the technical plenary session from now. So it's my great pleasure to invite first speaker of the plenary session. First speaker is Professor Muhammad Nashiruddin, PhD. Please join me in welcoming Professor Uddin to the stage. Professor Uddin, please. Okay, so before beginning his presentation, I would like to introduce about Professor Uddin. He is now in the Texas Agricultural and Medical University, USA. He was graduate from Biochemistry and Molecular Biology, University of Dhaka, Bangladesh, in 1919. So he got PhD from Gifu University in 2000. And his main topic is public health and disease. Okay, so if you are ready, please start your presentation. Are you okay? Yes, sir. Okay.
Good morning, everybody. It is always nice for me to return back to Gifu University as the alumni of Gifu University, though it is the more than 30 hours flight from USA to here, but I'm always feel good to when I come to see my alma mater, Gifu University. So thank you very much, the organizing committee, especially my longtime friend, collaborator, Dr. Kumaria, for inviting me to give a talk on this climate change conference. So whenever we discussed, so we realized that the climate change is not its own. It is related with the plant and with the health. So mainly in my presentation, I'll concentrate on how the climate change impact the health and well-beings. So let's start with I'm giving a little bit of my where I am at. So I'm in the Texas A&M University Medical School. Usually I teach the medical MD students, and I have a lab over there. Dr. Kumaria visited, some of them are visited too over there. Dr. Mitsunaga Sensei also visited my place. And then, next slide, please. So, it's not moving. Okay, and then I have a dual role in the university. I'm also serving as a research director for the medical student and residency and fellowship program. My research is on the disease of the public health interest, and which is funded by National Institute of Health. So this is my office here so that is one office, and another office is more than 100 miles apart. So in Texas or USA, this is very usual. So, and then, sorry, this having, okay, you know that today is the election, the election of the US election, right? So all over the people, all over the world is looking forward to the result for the election, right? So I start with some campaign from two potential presidential candidate of US presidential. So one is the the Kamala Harris. So her campaign, she asked the Americans to become unite. It means that people are not unite about the environmental health issues. She asked for unite and for build the historical work in the advancement of the environmental justice, protect public land, public health, increasing resilience to climate disaster, and continues to hold polluters accountable to secure the clean air and water for all. So it's very straightforward that there is a problem there till in one of the the toughest country in the world. They are struggling for the unity for their climate change problem. Yes, sir. I'm sorry. Okay, it's okay. Okay, and then President Donald Trump, he just criticized the unfair Paris climate accords and opposed the radical left Green New Deal. You all knows that those who are in in the environmental health specialist. President Trump, he called climate change a hoax, is a horrible situations or been a nightmare. He repeatedly used the word to describe the global warming on the social media platform X when he started in 2015 speech. He called global warming is a money-making industry. So, you know, the money-making industry, it means that there is a conspiracy there till policies and everything, right? That's how the scientists all over the world show their research output showing the adverse effect of the climate change on plant, and obviously, and is the human health. Okay, then I would like to go with some quote from some, the notable people. If you just started with the former executive director of World Health Organizations, Dr. Margaret Chan, she remarked that our ruined planet cannot sustain the human lives in good health, right? So a healthy planet is really a healthy planet, and healthy people are a side of the same coin, right? So Linda Rodloff, who is the director for the Climate and Public Health Institute, U.S. Climate and Health Alliance, she quoted, "Human need clean air, clean water, safe shelter, healthy food, and a stable climate for survival. We cannot have healthy people without a healthy places on a healthy planet." Ban Ki-moon, you all know him, just recent past Secretary General of the United Nations, he quoted, "Climate change is intrinsically linked to the public health, food, water security, migration, peace and security. It is a moral issue. It is an issue of the social justice, human rights, and fundamental ethics." Albert Einstein, long before, as a theoretical physicist, who quoted, "The world will not be destroyed by those who do evil." So it's the philosophical terminology, right? So somebody is doing the evil behave for the climate change, right? And one of the business magnate and then executive of the Apollo Hospital in India, she is very much positive that we are in bad situation on the climate problem, but it is not going to defeat us. We can overcome it. That's why we are here all today, right? Okay, you see that the intersection of the climate change and health is a pressing concern that exceed the environmental boundaries. As our planet undergoes unprecedented changes, the implications for human being are profound and far-reaching. So my talk aims to unreveal the intrinsic relationship between climate change and health, exploring how these dynamics manifest on a global scale and impact individuals and communicate alike. So the next 10-15 minutes, I'll discuss on that. So as we know that in schematically, we started with the climate change impact here. is directly impact on the human health, causes the injuries, death, thermal stress, infectious disease, infectious disease, malnutritions, mental stress, and multiple other disorders, health disorders. And indirectly, it causes the physical system, river flow, ocean temperature, soil, and then also affect to the biological, biological and ecological process, the plant, the crop yields, insect range and activity, etc. So which in turn, the indirect, which in turn affect to the socio-economical structures, affect to the jobs, conflict, and which obviously the end product is the human health, is affect to the human health, and then that all the ends with the adverse effect to the human health. So this is what in schematically, if we present the climate change on the effect on the human health. Key impacts that we discuss in this schematic diagram: heat stress, you know, the heat stress can causes the heart disease or some other diseases for elderly and young people, and breathing problem, respiratory problem. So you know that if the polluted air can causes the pollutions, causes asthma, and the infectious disease. Infectious disease, you know that COVID-19 is one of the example for us, which pandemic, which radically changes our human health all over the world. So, and then waterborne disease. So then global warming or the warming of the temperature of river, ocean can cause the growth of different microorganisms, and then it passes some diseases, which is the waterborne disease. Sorry. Right. And then it causes these all are the direct effect, right? So directly it affects to the health, respiratory system. Indirectly, it can cause the food insecurity. Food insecurity means then what is a lot of droughts and flood can lead to the food shortage and malnutritions. Mental health stress, whenever you do have the environmental health can causes the stress, anxiety, and the strained social cohesion and access to the healthcare. Economical impact, which damages to infrastructures and livelihood due to extreme weather, even can lead to the economic hardship, further impact on health access. I'm giving some real life. So is the again exposure, adaptations, vulnerability, health outcome. So they are all interrelated, right? How much you can adapt, how much are you are exposing with the extreme environmental conditions, how sensitive you are and vulnerable you are, that causes it depends on that, all the health outcomes, which is with the death event, hospitalizations, mental health, physical trauma, emotional distress, injury, chronic disease. Does all of this happen due to the changes of imbalance, right? Imbalance of the climate change, environmental health. So mainly, if you can define it, the environmental public health is one of the one of the burning topics nowadays, environmental public health. So that is under the environmental public health. So if you see here, this is very clumsy diagram. If you can see here, the increase in climate impact, for example, the dramatic spike in ocean temperature, top right, ocean temperature, if you compare for 1982 to 2023, how it increases, right? And then top left, and if you see the collapse of the polar ice in the lower left, coincide with the rise in eco anxiety systems amongst the younger populations in the top right. You see how it increases. And then in the, if you see in the right, the bottom right, where is the Philippines and India, those countries, in fact, 3/4 of the young populations are somehow affected or being traumatized by the climate change. As you know, that they have been growing with this one, with this, seeing the changes. So they are traumatized. So is not how is affected, the indirect effect, what is I'm explaining here. If you see here, I'm showing one of the slide from my own the country where I'm from, Bangladesh. If you see that, this is the southern central part of Bangladesh. You see, there are been is in the Gulf, it is the Bay of Bengal. So Bay of Bengal, you see nearby that you see that you see the people and then the animal. So all are being in danger, right? And then it's happened for the food and water insecurity. So that causes the trauma, and then eventually that lead to the adverse outcome. So if you do not have the sufficient opportunity, you don't have the environment, even at your home, if you will not give a good environment to your children, they will not grow well. Their mental health will not be good. So you should be careful on that one. So globally now, the countries like the underdeveloped countries, they're mostly directly affected by the environmental changes. This is one example of my back home country, Bangladesh. And then is the Indonesian, and then the some other countries like the South America. I have another slide for, sorry, I'm not good at that. You see that Spanish word which is called the, El Nino, which is the warming of the ocean surface, which the temperatures is the Indonesia, descending dry air, and then the South America, and then it causes the warming and the rising moist air. I know that last year I visited Indonesia. It's very moist, right? It's very moist. The climate is so this is due to there where they are at, right? So people adapt, but there is a long-term effect is there. The productivity of the people may be much better than now the situation is right now. So I need to, I'm taking a lot of time. So that's why I would like to go a little fast. You see that, how the disasters, the red one, you see that is highly affected is of the, some of the study of the Catholic University in Belgium. So number of the victims is been increasing. Environmental health, if you see here, the temperatures, how it increases, and their mortality, is been going high. Okay, so now we've been going through the direct effect on the climate change. on health risk. You see the vulnerable factors or the demographic, geographical, biological factors, socio-political, socio-economical, healthy system capacity, and gender and equity, which this causes the health risk. What are the extreme weather, heat, sea level, air pollution, a vector contributed for the, microbial disease, water scarcity, reduce the food productions, which exposure can causes the health worker and energy system, infrastructure, health system. However, you see that it rises from the health system and facility. They emitted the greenhouse gas. So, and that causes all this effect, right? Increases this one. However, and health outcomes is there. So how you will consider this one? How that we can interrelate this one? It means that we should minimize, we should minimize the health system, health facilities, the emissions of the gas. We need to be careful how minimum gas we can, the industry, healthcare system, pharma, the emissions can be reduced, then this whole system will be. That's what I showed, that it's been happening and causes all the health hazardous. And then aside by that one, the health system is here. So, but they are causing you to come to the hospital, right? So that's how I started with the two presidential candidates election campaign, right? So that is some politics is there, some business is there. So we need to minimize that one. That's how we need to become with. I'm how many minutes I have? I'm fine. Okay, thank you so much. Okay. If you see that climate driver, if you see here, I'm sorry, this is very in busy. You can see that one, but if I can just make it very simple, that extreme heat can causes the rising temperatures and will lead to an increase in heat-related death. Outdoor air quality, which causes the asthma and then some other airborne diseases. Flooding, as I showed that in Bangladesh or countries like that, the flooding can cause the socio-economical and mental stress, and then increase the anxiety for the young adult, right, about the 18 years, they have been mostly affected on that one. So vector-borne infections, as that you see that we know that the microbial diseases, they are being transmitted to the vectors, and water-related infections. When the water is warm up, some microorganisms they reform, they mutate. Is that like the COVID-19 coronavirus, it is been due to the people believe that this is the global warming. Some of the virus, as the swan virus is mutate, and then it's made a very virulent strain. And now it's changing now, that what will coming next, we don't know, because we didn't control the global warming, and then spontaneously it's muted. Okay, so that is something like the increased global temperatures, extreme weather, so changes climate, which are the factor precipitations, extremes, sea level rise, change in land use and growing seasons, and which extreme heat, it's called extreme heat, air and water pollutions, reduced food and water quality, and sea level, which changes the infections, as I mentioned right now. And then the changes in land use, which causes the increase in the allergens, the allergens, which causes the, multiple diseases. And then health impact. So heat-related illness, cardiovascular problem, injuries and death, mental and neurological disorders, and respiratory disorders, and how we can intervention strategies. I'm giving a little bit here from next few slides. I'll go over with how we can mitigate or adapt this one, and what public health policy we need to be implicate for these remediations. So, as if we would like to see how it can causes the global health crisis. So we discuss how it impact to the health, but is the global health, how it the environmental change or the climate change, how it changes the global health and raises the global health concern. The climate change exceeds the traditional categorizations as an environmental challenge emerging as a difficult global health crisis. And it intricate interplay between environmental shift has been shifting from one level to another level, and create a complex that poses the unprecedented challenges for healthcare systems worldwide. Extreme weather events, including the hurricane, droughts, and flood, resulting from climate change, not only causes the immediate casualty, but it has the long-term effect, long-lasting effect. These altered ecosystems can delicate balance, so disrupt the delicate balance, the biodiversity, exposing the population to new vectors and disease. The transformations of the agriculture patterns contribute to malnutrition and food insecurity. So is immediately climate change causes the mental health issues like the anxiety, post-traumatic stress, and long-term disorder due to the factors like displacement and disrupted social cohesion. Is the climate risk? As I said, these are all the factors, and then it causes the health impact. So this may be the respiratory, infectious, neurological. So I'm just breaking it down to trying to make in a funnel, for the bigger funnel, to making this to be some point. Then we can discuss a little bit how we can mitigate and adapt these issues. So as you see that the diseases is mostly we know that genetically involved, food is there, but different effect, but the environmental health changes causes all of the changes. It can causes all these disease. Okay, so you see that the physical environment is a threat multiplier. It means that it can multiply. If you have the more than one factors, the risk will become multiply, right? So if you have the one factor, is a normal mathematical terminology, right? The one factor, if there's a two factors, three factors, is multiply the risk. So this is how the different factors, if there is a factors like the warming of the water, sea level, and other factors, it multiply the risk factors also. Okay, that is the same rising of the multiply. So I don't like to go in details on that. Okay, now the holistic approach, which I started, the holistic approach, how the multidisciplinary actions needed to address the environmental change or environmental effect on the human health, how holistically we can combat that. So first we can start the mitigation strategies. What is the mitigations? Reducing the greenhouse gas. We all know that, right? So emissions through the transition to renewable energy source and sustainable practice to limit the severity of the climate change. So do you have any ideas to how we can do that, right? We cannot do it in one, but there should be some policy. So if you can allow to use some of the things, right, you can tell you reduce, right? You can have some rules, some policy making, and some level, governmental levels. So international levels, so some advocacy committees there, they're trying to see for the public health issues. So it's a big public health issue. So environmental public health, as I mentioned to you, there is a lot is going on that, because that is the burning issue nowadays for address the disease and to keep to uplift the burden, economic burden for the public health issues, to address the public health issues. So if you see here, the mitigations, transformation, and adaptation. So you can see the low carbon level, recycling, and virtual and digital care delivery. So you have no need to go to the doctors. You can do nowadays is COVID. You know that mitigated some of the health. Doctors. You can now. I don't know here in USA, so you can go to the online to see the doctors in online, right? Mitigate, and then this way maybe you have no need to drive, so no need to emit. Now they have the car. So Elon Musk had the Tesla. You know that it's been there too. So and then but again his battery is very dangerous, as I know that, but they're trying to see how they can do that. This all are the policies we need to be made, and adaptations. Early warning system. So we have these early warning systems. So for developing a system to alert communities about upcoming extreme weather events. It's been going all over the world. Maybe now they have the early warning systems. Heat adaptations plan. You need to how you can adapt the heat. So and then campaign is needed for to make the public awareness, improve the healthcare infrastructures. So healthcare infrastructures providers should be strengthen their healthcare system to respond to the climate-related health emergencies, right? Not only the chronic diseases, but also the climate change related healthcare health emergencies should be considered as a emergency, and then it need to be aware of everybody. And community resilience building, so which is empowering the communities to prepare for and recover from climate related disasters. So intersectorial collaborations, that is I'm now narrowing down it, all this effect, but intersectorial collaboration means we need to make the health sector engagement. So that should be, okay, somebody didn't mute, right? So integrating climate change consideration into healthcare policy practice. So healthcare engagement, collaboration with policymakers, advocating for policies that address the climate change and public health. So you need to be protect the public health. Community outreach. So you need to educate the communities about the health risk for the climate change, not to use it, social and physical environment. And promotional models. The promotional models, you can see the one sector invest in another sector to address factors that impact on own outcomes. executive leaderships. So that's I started with a few quotations from some executives from different organizations that we should follow that, right? That's why I started all these points and ending with how we can address them. Yes, we should address them. So, at the policy level, uh, urban greening, obviously. I saw in last year when I visited Indonesia, there is urban, so they're doing a lot of the green and the lot of tree is there. So that is good. Otherwise, the warming should be more, but it's been going on. But it should be all over the world in the developing countries and focus on the SDG. So you know that I don't like to go in details, but you all know the SDG, right? 17 point. So one of the point is uh, the environmental sustainability, economic sustainability, and social sustainability. Is the SDG is one of the goal. So we need to meet the goal for SDGs. Dr. Komaria and those people in the this conference, they are really trying hard to reach the goal for the SDG goal for the environmental that sector. If the 17 points. So, okay, I'm going a little fast. So, and then political mandate, as I saw that both of the presidents, I know that by these today before noon, we'll know who will be the president of the United States of America. They can come up with the campaign they started with the 1st of March. They should come up with, obviously, they said in the campaign, they should implement it for the political mandate, right? So they have the political mandate. So I don't, for the Genovia, you know, this is one of the basin in Eastern Central Europe. So that is been the one of the model utilized for the modern world for the climate change, to testify the climate change. So that they are working the way for making the stakeholders how to address the adaptations and mitigations. Okay, a key point we need to consider. I'm about to be finished. Two more slides. Sorry, one more slide and last one slide. Right, vulnerable populations. Right, what are the vulnerable populations? So those who are elderly people, who have the underlying, conditions. So you need to take care of them and not to expose them for extreme weather conditions. Mental health conditions, you need to recognize the significant mental health impact on climate change and provide access to mental health services. You need to give the mental health services. And then another one health approach. How many of you know the one health approach? The students, not the faculties. You know, right? So what is the one health program? You know the One Health program, health for plant, health for animal, and health for human combinedly. So you can make in a model, you can address all these diseases by one health problem, one health. If there is a veterinary scientist here, veterinary scientist is one of the key factors, key component for maintaining the one health uh, address. So you can one health. So if you take care of the plant health or the animal health, then you can address the same way you can address the human health. So this is my last slide, policy. So I don't like to go in policy, so I can I would like to happy to be. So I can end up with the slide. There is no planet B. So it's only the planet A. And then think green, live green, fight global warming. Thank you very much for listening. And then
Thank you very much, Professor Udin. So actually, I forget to take the break after photo session, so you have enough time.
yes, I have enough
So
time.
now,
Okay.
we can accept your question and comment from floor. Are there any comments? Okay.
Thank you so much. I appreciate for your presentation. I also interest with your climate change health impact pathway, Mr. Nasaruddin, Professor. Development with the pentahelix model involving the government, the private sector, private university, and mass media, also all people. But has this model been implemented, and to accelerate the better situation, what is your suggestion? Because it involves various parties, also sector. Thank you so much.
Yes, thank you very much. This is the last things which I am trying to address that. So model is there, stakeholders are there, and they are acting over there. But you know that something is over there, so which is the politics, global politics, and then the business is there. So we need to bring more the stakeholders for businessmen, for some, all the billionaires should come, all the healthcare sectors, the owners, and they should come forward, and pharma, they should come forward. Obviously, policy making there for the implementations of that one, right? And then only that can be implemented.
Yes, thank you so much.
Okay, thank you very much. So are there any comment? I can accept one more short question. Okay. Yes. Okay, Zoom guy, please.
Okay.
Just a moment.
Mr. Azman Hossan. Sorry, I don't know how to. I think you should stop screen.
Yes, so yes.
Hello.
Yes.
Please.
Please, we
Can you
can
hear
hear
me?
you. Is a midnight. How about the election?
It is going still well. Thank you so much, Dr. Nasiruddin. I'm so glad that for your well-organized and thought-provoking presentation on the connection between climate change and health. And my name is Azman Hossan. I was supposed to be there, but unfortunately, due to a family emergency, I canceled my trip. And currently, I'm joining virtually from Colorado, United States. So I would like to thank you, Dr. Nasiruddin, for your well-organized presentation. And I'm so glad that you brought a holistic approach in dealing with the connection between climate change and health. I know you are a medical professional, but you navigated how the socio-political and economic aspects can interfere in the connection between climate change and health. So I have a questions like you have a wide varieties of experience in your research and academic career. You are from Bangladesh. You did your PhD from Japan, and now you are in the United States doing research and teaching medical education. So whenever we are talking about like socioeconomic aspects of health, if we look at the World Health Organization's health definition, health is a state of complete physical, mental, and social well-being. So given your experience from Bangladesh, then Japan, and then United States, how do you see the differences that how our socio-economic and political aspects are affecting the connection between climate change and health? Specifically given the history that USA is a highly racialized country, but in Bangladesh, race is not an important factor, but it is highly unequal country in terms of income, in terms of socioeconomic like status. So how do you see the difference between different countries?
Okay, thank you. Dr. Hussain. Thanks. You are been, it's midnight your place. You are been wake up and then you are listening to us. So yes, I agree because I have the diversified experience to be being in Bangladesh, Japan, and USA. So, you know, the first, I know that I need to learn from you. I know that you are a specialist on that field. So sustainable environmental health and then policy. We wish you could be here. We have more discussions. But for my layman, you know, the layman on that field, I can tell you that one thing is the difference of the, you know, the insurance is a big factor, right? Insurance is a big factor. Healthcare, people cannot go to the doctors, cannot get the good healthcare. Obviously, this is one of the factors for economical standpoint, but social standpoint. So if I went to Indonesia, there is a lot of tribe is there, right? So you know that is whenever they have the you know, if you consider their general health is different from one race to another race. One if I say that exactly for Bangladesh also diversified. We have different people came in. We are being also for Japan is really the I tell that is a monoclonal, right? So they are all look similar. They are all same. So their health problem are same. So they are healthy and they have their you know. So if you like to write, if you come to the global aspect, you cannot combine these three parameters. You need to set different parameters to address these different type of countries. That is what you want to, maybe I can, okay, you want this answer or you want more?
Thank you, sir. Yeah, you responded very well. I really appreciate.
Okay, thank you so much.
Okay.
Listening us.
Okay, thank you very much for due to the time limitation, we have to move the next speaker. But yeah, actually, so Professor Udin is a fellow of the American Heart Association. So I would like to ask what action are they taking American Heart Association for regarding the climate change. But time limitation, I will ask you the
later on, right?
Yeah, later. Okay.
But I just say only one word. American Heart Associations, they are funding for the public health issues. Any public health issues you go, this one, they're giving the funding for doing the research for that one, right?
Okay, thank you very much. Due to your active discussion, so we can catch the time. So please give applause again. Thank you very much, Professor Udin. Okay, so we would like to invite next speaker, Professor Hiroyuki Muraoka. Okay, please welcome to the stage. So as you can see in the screen, so Professor Muraoka is also the Director, Center for Environmental and Social Sustainability, Gifu University. He got PhD in Tsukuba University in 1994, and then moved to Gifu University. And then, so his expertise area is plant ecology. So we can hear how impact the climate change on the plant ecology today. Okay, so please start your presentation if you are ready. So for our participant virtually, please mute your microphone. So a little bit difficult to manage the hybrid mode. So it's so quite issues, challenge issues.
So, Professor Nakano, thank you very much for introducing me. And ladies and gentlemen, thank you very much for having me to give you a brief overview of to introduce about Takayama Field Station that many of you will visit on this Friday. And I appreciate all this organizing team of this great, thank you very much. Great international conference on the climate change. So again, my name is Hiroyuki Muraoka, a professor and director of the Center for Environmental and Societal Sustainability in Gifu University, and also I'm committing to National Institute for Environmental Studies in Japan to take a role of the group leader in the biodiversity division. So this picture shows you the autumn scenery of the Takayama site. Just this morning, the picture was taken last year or 2 years ago, but this morning I checked that the leaf fall has begun, and then on Friday, I think that you will see some yellow or red leaves in the foot of the Takayama Field Station. So already Professor Udin shared the very recent situation of the global climate change. So let us try to focus on our Asia-Oceania region. So we all know that the Asia-Oceania region is characterized by complex geographical characteristics, large population, including us, and drastic climate change, natural disasters occur frequently, and I know that the Secretary General of the UNDRR always said that we don't have the recent disaster due to the climate change is not natural, but this is anthropogenic. I mean, because this is caused by the human activity. The climate change is caused by the human activities, and so that the disasters are also not natural, but due to the indirectly by the human activities, and rapid, diverse socio-economic development and deteriorating ecosystems. But we also know that our region is characterized by high biodiversities and rich ecosystem services. And as you see here, I borrowed this figure from the IPBES assessment, and our region is characterized by diverse biodiversity and ecosystems. Then again, we know that the atmospheric CO2 concentration is increasing in spite of the some rapid decline due to the global international situation, including the recent one is a COVID-19, but already the growing concentration of the greenhouse gas emission is already recovered, as I said, that at the opening remarks by Professor Hiramatsu, that the CO2 concentration now is reaching to 420 ppm. When I was a student in the Gifu University, I measured the leaf photosynthesis, and at that time the CO2 concentration was about 350 ppm. So we have in the last 30 years we are experiencing more than 70 ppm CO2 increase. I mean, 20% wasn't nearly 20% increase of the CO2 concentration. So we are also interested in how, where, and how much the emitted CO2 is going in our biosphere. According to the recent report by the Global Carbon Project, the headquarters is located placed in Australia. As you see in the left-hand side, in the last 150 or 60 years, the emission of the greenhouse gas is increasing, as we know. And the question is that where and how much those emitted CO2 goes in that biosphere. According to the report, about 26% is absorbed by the ocean, including the some plants in there, and about 31% is absorbed by the terrestrial ecosystems, including the forest, grasslands, etc. And about 47, I mean, about half of the emitted CO2 will remain in the atmosphere every year. So this is the reason why the CO2 concentration in the atmosphere is increasing every year. As we already experienced in the last few years or 10 years, the temperature is increasing, of course, in the worldwide. And we will remember that last year we experienced a quite high temperature worldwide. Of course, in Japan, we also experienced that. And this year, probably the record will be updated, and then we will see more higher temperature. And already we are the global warming since the late 19th century is almost approaching 1.5 degrees Celsius, and this is one of the critical threshold for facing the climate crisis in the world. So we also know that if we look at the data from the meteorological agency, the global warming is accelerating. If you see the left-hand side, this is a air temperature increasing per decade in the last 130 years. But if you see the red points, the red, I mean, the degree of the curve means that the degree of magnitude of the increasing temperature. And the right-hand side, this is for the data between the 1980s and the recent, I mean, recent 40 years. You see more red marks on the world. It means that the temperature increase is accelerating in the last couple of decades. So that is one of the reasons that we are facing the planetary boundaries. That this is the maybe many of you know about the planetary boundaries. We have the environmental crisis, including the climate change, biosphere integrity, land system change, freshwater change, biochemical flows, ocean acidification, atmospheric aerosol reading, and ozone, some novel entities, including the plastics. So we have a lot of challenges or environmental quite critical environmental issues that at every level in the society. Now we would like to focus some about to our ecosystems. As you see, our planet is covered by was covered by rich terrestrial ecosystems, showing by green. This is just a seasonal change of our terrestrial ecosystems. But the question is that how much they continue to regulate our atmospheric environment for the more sustainable Earth system. So let's think about our forest. We are very much familiar with the many kinds of forests that because both in Indonesia, in Japan, and also in the East Asia, Southeast Asia, we are surrounded by forest ecosystems and we are very familiar with those. So again, forest, I mean, the plants absorb the carbon dioxide from the atmosphere through the photosynthesis, and then they generate the primary production in the ecosystem level, and this primary production support the food web and habitats for the wildlife's biodiversity, and then those forest functions and biodiversity support our daily lives. But our question, I mean the scientific question, is that what are needed now to know more about the conditions of the forest ecosystem functions under this climate change, or more, if we think more about our human impacts on our natural ecosystems, we need more scientific activities or outreach to society about the detecting the impacts of climate and societal changes on ecosystems and biodiversity conservation and ecosystem management for fostering mitigation of and adaptation to climate change and sustainable use of natural resources. So we have to, I draw this illustration about 15 years ago, but still we have to address this kind of scientific questions by integrating many different kinds of scientific technologies, approaches, and also people from the different disciplines. Now I'd like to introduce some activities in the Takayama Field Station that many of you will visit on this Friday. So we are now in the Gifu city, and then if you take about 3 hours, 2.5 hours drive by bus on Friday, you will get to the Takayama city, and then if you take bus another 30 minutes, you will reach to the Takayama Field Station. So since 1993, I mean, not only the faculty members or students of the Gifu University, but with the cooperation with the many national institutions or universities in Japan, we have been observing the CO2 budget. I mean, the exchange between the atmosphere and the forest of the carbon dioxide through these micrometeorological observation towers in both the deciduous broadleaf forest and evergreen coniferous forest. These two types of the forest ecosystems are quite typical for the Japanese forest. There, I will introduce some of the data from this Takayama Field Station from now on, but in the last 30 years, we have been making this kind of long-term multidisciplinary observation for the forest ecosystem functions to detect or to understand how the forest ecosystems what are the role or functional role of the forest ecosystems in the climate change era, and how the climate change impacts to these forest ecosystems, which are crucial for the sustainable Earth system. We have two carbon dioxide measurement towers, and many other equipments or infrastructure to measure all the leaf photosynthesis, soil carbon dioxide, and soil CO2 flux, tree growth, etc. And then we integrate all these data together to analyze to explore the dynamics of the CO2 concentration in the atmosphere, and also to assess the daily CO2 uptake by the forest under the changing environment. And then we try to also develop a kind of simulation model to predict the future situation of our ecosystems under the climate change. Of course, we have to mind about the disturbance due to the typhoon or plant growth, etc. So we have a very complicated system here. And then to reveal this complicated system, we need a multidisciplinary approach to understand this system. Then this data and knowledge could be delivered to the society or academia to mitigate the climate change or to manage the forest and also to know about our environment at the society level. So this is the view of the Takayama deciduous forest site in summer. And this is the view in the late autumn. Now you see in the, this is a view of the deciduous forest site. And then I will show you about the coniferous forest later. And we have the canopy observation tower and the CO2 flux observation tower. We have the forested landscape here. And at the top, you will see the Takayama city there. This is one of the research site. So again, our deciduous forest in summer and the winter in the same place. I mean, in the winter so far we had a 1.5 meter or 2 meter depths of the snow in the middle of the winter. So this is the picture I taken 20 years ago when I was a postdoc researcher here. So of course, on this Friday we still don't have snow yet, but this is the one of the places that you visit on Friday. Then here in the deciduous broader forest side, our friendly colleague, National Institute of Advanced Industrial Science and Technology, which is based in Tsukuba, Ibaraki, they installed this kind of 30-meter height observation tower here, and they measure the atmospheric CO2 and the exchange of the CO2 between the atmosphere and the forest ecosystems. So this data, of course, we use this for our own research, but these data are also shared with the international activities for observing the Earth system. For example, the CO2 concentration of the atmosphere is delivered to the World Data Center for Greenhouse Gases that is managed by the World Meteorological Organization based in Geneva, Switzerland. And then this CO2 exchange data is shared with the Asia Flux Network or FluxNet network in the world to study about the net ecosystem production due to the photosynthesis and respiration. And at the top of the one of the forest ecosystem tower, we have these many kind of equipments. And we, in the last more than 20 years, we are observing the phenology of the forest canopy. Phenology is the seasonal change of the organisms. And then as you see on the right-hand side, we have the seasonal change of the forest canopy and the forest floor. And the question is that why we observe the forest phenology? Because we already know that the plants and forest canopies change seasonally. It means that the photosynthetic capacity or photosynthetic activities changes seasonally. And if you observe these seasonal changes over decades, then we know that the timing of the leaf expansion or timing of the leaf coloring, leaf fall changes every year. due to the short-term level environmental changes, because the leaf development, leaf fall are responding to the environmental conditions like temperature, soil, water, or radiation. Mainly, the temperature is the driving factor for this seasonal change. Then, if we combine this CO2 exchange between the atmosphere and forest ecosystem, and then the data of the forest canopy seasonality, we know that the seasonal change of the CO2 uptake by the forest changes every year due to the changes of the leaf phenology and also the changes of the summertime environmental weather, micrometeorological weather conditions for the photosynthesis, because we know that leaf photosynthesis is affected by radiation, temperature, water availability, and so on. So, and we know that every summer we have somewhat different weather condition in the natural environment. And after 30 years of these observations, this is a very new data. We published this paper in last June by integrating the data from about 30 years at the deciduous broadleaf forest site. And each dot represents the yearly annual photosynthesis, annual respiration of the ecosystems, and annual net carbon fixation of the ecosystem. You see that every year, the net carbon fixation, which is the balance between the photosynthetic CO2 uptake and respiratory CO2 emission, changes drastically. In some cases, we have the disturbance of the forest canopy due to the typhoon. But after the typhoon disturbance, we see that the recovery of the forest canopy and then the photosynthetic capacity of the forest level recovery. But you see, after, let's say, 2013, I mean, in the last 10 years, you see that photosynthesis and net carbon fixation is decreasing. But we don't have any signature of the forest disturbance. Then the question is why the forest canopy reduces its carbon fixations. We are now trying to explore that reason, mechanisms, and we have some idea that maybe the recent climate change, particularly in summer, increasing temperature, decreasing the atmospheric humidity, causes some stress to leaf photosynthesis. We don't have the evidence yet, but we are trying to explore that. So let me introduce some activities in our evergreen coniferous site in Takayama. We have the PI here, Dr. Saito. I think he's sitting right there, and he will also take you to this site on Friday. And this is also one of the longest research site in Japan. 20 years ago, we installed these observation equipments, including the CO2 exchange systems or the soil respiration subflows, spectroradiometer, and soil respiration, tree growth, etc., to investigate the carbon cycling mechanisms there. The question, one of the highlight from this evergreen coniferous site is that they experienced a disturbance due to the sudden heavy snow many years ago. So if you see this photograph, we had kind of quite heavy, humid snow in middle of the December in 2014, and this destroyed this forest canopy. Then we had a very big gap in the forest canopy, and then if you see this right-hand side graph, we have the GPP is the forest level photosynthesis, RE is the forest level respiration, and then NEP is the net ecosystem production. This is the net carbon gain of the forest. And if you see the black lines, this is the data before this disturbance. And other colored lines are after this disturbance. You see that, interestingly, GPP did not change so much, even if we compare before and after the disturbance. Of course, we have the slight changes, but we see that ecosystem respiration is, we see that quite big difference between the black line and the red line or others. It means that this forest ecosystems reduced its respiratory CO2 emissions. And then as a result, the net carbon gain of this forest increased after this snow disturbance. We also, Dr. Saito asked why this happened. Because we imagine that if the forest canopy is destroyed, maybe the photosynthesis will be decreased. But he showed that, as you see in the photograph, you can compare the understory condition in 2005 and 2023. After the disturbance of the forest canopy, the vegetation of the forest floor was increased. I mean, many perennial herbaceous plants and shrubs are introduced, and then the forest understory vegetation is increased. Then we have the richer, at the forest level, we have the richer photosynthesis at the ecosystem level. Then the question is that next, our challenge is that not only for the Takayama, we also want to know about the many forests in worldwide. We have the international efforts to gather all these observation data or knowledge in worldwide. I would just briefly introduce the two of those activities. One is the long-term ecological research network. And of course, we have these networks in Japan. We already have 60 research plots in Japan. And globally, we have more than 700 sites from 44 countries or regions. Then by integrating those data or knowledge about ecosystems and ecosystem services, we can know the mechanisms of the ecosystems and the functions, and then also we can detect the changes in worldwide. Another activity is the Asia Flux Network. This is the research network to measure the carbon dioxide, heat, and water by using such observation towers. And Takayama site is one of the oldest one in the world. I mean, we have the longest history of the data. Then by integrating those observation data about the carbon dioxide exchange between the atmosphere and the terrestrial systems, we can know how these forest terrestrial ecosystem functions change across the altitudes or the climate gradients. And also by combining with the satellite remote sensing data and model simulations, we can have this kind of map of the primary productivity under the climate change. So these two international efforts to convene the observations data and also to advise the young generation researchers. We have this kind of the Takayama side and I would say Takayama community it has been contributing to grow this kind of, develop the capacity for the ecosystem research in the climate change era. So one of the example from the HF-FLAX networks is that, as you see from the north to the Northeast Asia to Southeast Asia, we have many different kind of forest ecosystems. And if we measure the CO2 flux throughout the year, we know that there have the drastic changes of the seasonal change pattern from north to south, reflecting the differences of the climate and forest ecosystem structure, I mean, including the species composition. So, so far we know that the forest ecosystem are quite important for us to mitigate the global warming and also the climate change adaptation. But to conclude my presentation today, I'd like to share some issues that we have to know. Of course, at the Northern Hemisphere, global level, by using the satellite remote sensing data, we already know that the continental level phenology is changing due to the global warming. For example, in the Northern Hemisphere, the spring temperature rising causes the earlier date of greening, I mean the leaf expansion, and the warmer autumn result in the increasing temperature in autumn leads to the very delayed leaf senescence in the hemisphere level. But the problem is that, as mentioned by Professor Udin already, the human activities have been impacts the natural systems globally. I mean, we utilize the biomass, natural resources, and the biodiversity, and also even the changes of the land use will change the soil organic matters. I mean, we have been changing these natural systems worldwide. And then we are facing the global warming or climate change. And then what happened to our forest ecosystems? This is the paper that published 10 years ago already. This research group already found that at the continental level, the many forest ecosystems are facing the heat stress or drought stress because of the climate change. Also, this is a paper published 3 years ago. We actually, again, I mean, human beings have been depending on the natural ecosystems like forest. But the climate change and the land use change cause the change the forest ecosystems from the absorber of the CO2 to the emitter of the CO2 because of the environmental stresses like drought and heat and land use change. Of course, we know that our society or economic growth needs to utilize the natural systems, but we have to mind about taking balance of those. So again, we are facing the planetary boundaries at every level in the society in our world. So last year, Gifu University and Nagoya University, we developed the kind of team to establish the visioning strategy to address the societal issues in the global climate change era. We discussed about the needs of research, education, social engagement, international cooperation, particularly about the carbon neutrality, mitigating global warming and climate change adaptation. And then at that time, we also discussed the importance of recognizing the remote responsibility to the environment and natural resources, that key. Then this year, I belong to the Center for Environmental Societal Sustainability, but this center was set up this April. in the last couple of years in the Gifu University, we discussed that we need a kind of new research and education, new research and capacity development research center to connect from the basic science to the applied science for focusing on the environmental sciences. So we integrated 3 different environmental related research center. One is a river basin research center. Second one is a regional adaptation research center. And third one is the carbon neutrality research center. And then we developed this new center for environmental and societal sustainability to address the science society cooperation platform to support regional nature positive. Then, of course, this center focusing on quite local or prefectural or domestic sense regional level activities, but by addressing this climate change challenge in the society, we are trying to share this kind of outcomes with the society or with the academia in Japan, also with international cooperation networks. So our focus is that sustainable use of natural resources, conservation of biodiversity and ecosystems, transitions to renewable energy systems, mitigation of and adaptation to climate change. Then we want to pursue the better balance of natural ecosystems and human society. As already Professor Udin mentioned that we are pursuing the SDGs, but the good economy depends on the healthy society, and healthy society should be based on the healthy natural environment. This is the key of our SDGs. So I'd like to conclude my presentation and thank you very much for listening. And I hope that this symposium will give you a very new insight. Thank you very much.
Okay, thank you very much, Professor Muraoka. So due to time limitation, so we cannot accept your question from the floor and online. But he will attend our excursion on Friday. So if you have any questions, please ask him directly on Friday. Of course, he will join the banquet today. You can ask your questions. Okay, thank you very much, Professor Muraoka. Please give your thumbs up again. For the participant online, so you can ask your questions using chat system. So if you give a comment, we will forward to the Professor Muraoka, and he will reply to you. Okay, so next, I would like to move the last speaker of the keynote session. So can you show the slide of the, yes, thank you very much. Okay, I would like to invite Professor Dr. Hadiwiano from, Surasmaret University, Indonesia. Okay, Professor Hadiwiano graduated from Universitas Gadjah Mada, and then he got a MSc in IPB, Institute Petranian Bogor. My pronunciation is correct? Okay, so he got PhD at Universitas General Sudirman. Is it okay? Okay, thank you very much. Okay, his expertise area is plant pathology. Okay, please give your presentation if you are ready.
Okay, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. And how are you today? Fine. I hope you was very happy. And for me, this day may be very happy. It is my second coming in this
Gifu University. Thank you, committee has invited me. Ladies and gentlemen, as from the committee that I should be have a sharing of about the effect of global warming on the development of tropical plant diseases. Oh. Okay. Okay. Yeah. First, I would like to show the systematization of contents our presentation. First, for introduction, I would like to talk about the important role of the environment on plant disease. And second, effect global warming on tropical plant health. Third, effect of global warming on tropical plant pathogen. Fourth, effect global warming on insect-borne diseases. And five, and I would like to share interesting cases of plant disease epidemics, such as an impact of global warming. And six, for closing, I will talk about the mitigation through plant health management. We try with the introductions that the ladies and gentlemen, we realize that global warming and its impact are hard to avoid. And global warming impact all aspects of nature and life. Plant pathogen or plant pathogen are no exceptions. And also the interaction of plant and pathogen also, I think, also no exceptions. So because our title talk about the climate change, I would in this slide I would like to what is it? Talk about the characteristics of tropical climate, especially characteristics in Indonesia, that they have position on the equators from 6 to 11 degrees south latitude and 95 to 141 degree east latitude. Characteristic tropical climates in the tropical is significant difference from the subtropicals. In the tropical climates, temperature, for instance, high average temperature, and then high humidity and high annual rainfall. Yeah, and it is very different with the characteristic of the subtropical climate, and maybe can be representative by the temperature, because the subtropicals have summer and winter, so the temperature range may be very wider, much wider than tropical. Yeah. So this condition, this environment, I think will affect the organism living in it. Okay, because we talk the disease, we must what is it? Review about the concept of plant disease related to the effect of environment to plant disease occur. Basically, that the disease can occur if plant genetically susceptible and at a susceptible state. Second, pathogen is genetically virulent and at virulent states. And third, the environments must be favorable for expressing host plant susceptibility, phenotype, and pathogen virulence. So briefly, that the three factors should be supports this interactions. If one factors not support, the disease will not occur. Okay, we come to the next. Okay, we talk one by one from the three factors. First, the influence environmental changes on plants on hosts. And we talk plant head. Plant head. Plant head is a phenotype of plant. That the result of interaction between plant phenotype and environment. The result of interaction of plant and pathogen, at least there are four grades of interaction or type of result of interaction. First, resistance. Resistance means that actually the disease occur, but in mild disease intensity. And susceptible, the disease occur and severe disease. And tolerable, and the disease severe but mild impact. And the last, immune, mean that no disease. The disease can occur because the interactions between pathogen and plant is incompatible. Or maybe if we talk about the genetic, maybe the disease is the result of a genetical reaction between plant genetic and pathogen genetic. So in this case, immune means that the interaction is incompatible. Anyway, we continue with the plant head. Related the impact of global warming to plant head. Many way can increase the plant head, the global warming. First, that the global warming that maybe will change climate and weather and increase air and soil temperature. The temperature will increase the respiration. We know the respiration is a burn of carbon. So in this case, the carbon result of photosynthesis burns through respiration or through oxidation. So what this is sometimes called as the energy losses, because the carbon that resulted from the photosynthesis burns through respiration. The second, that the change of climate and also temperature will affect of population pest, increasing pests. Pests can directly, can cause damage plant, and indirectly, the pests also take a role as a factors of pathogen. So in this case, this is the second, if the population increase, factor increase, so maybe the disease will increase. And then I will want to stress global warming as an impact of global warming also can cause a physiologic disease. Physiologic disease mean that the disease caused by what unfavorable condition from such as also including the environmental stress or non-pathogenic or non-infectious disease. The more problem that the physical disease can predispose infectious disease. So the problem to be complicated, that especially some disease, especially weak pathogen. Usually weak pathogen will increase the virulence if get host in weak condition. So it is that many way and the end can declining growth and zealous of plant. We move to effect of global warming on tropical plants pathogen. Commonly, the organism in tropical tropical zones that they have, what is it? They adapt in the temperature range, temperature in tropicals. They survive and will increase the biological activity at range around 15, maybe about 15 degrees Celsius to 40 degrees Celsius. So in this case, also plant pathogen will, if they, what is it, in around temperature increase, they also increase the growth, the population, and the activity. Okay, it is an examples, at least three bacterial diseases on onion that they increase with the increasing the temperature. Okay, we in this moment I also going to talk what is it. I would like to share about the risk of climate change on plant necrotrophic disease. Necrotrophic disease mean that before absorb, before take nutrition or food from host cells, they must be killing the cells. After killing, then the pathogen takes the nutrition and food from the killed cells. It necrotrophic, and the characteristics of necrotrophic pathogen, they, what is this? Will more virulence. On the virulence will increase in the weak plant. So the environmental threat that makes weak plant can increase the risk of necrotrophic plant diseases. Climate change will increase the risk of necrotrophic plant diseases. This I give some examples, such as basal rot of garlic, basal plate rot of shallot, that I will discuss more in the next slide, and so on, and many necrotrophic pathogen. Yeah, and also it is important also, if we talk climate or weather, maybe all phytopathologists will remember with the what is it that the disease occur, and this is explosive will determine or close related to the what is it, the weather. What is it? The epidemic disease. The characteristics of very epidemic disease very determined by the weather, especially air humidity. If the air humidity condition above 40, 80% arid for a long time, it will be very damaging to plant. This condition can be, what is it? The impact of global it is can occur. So for epidemic disease, an early warning system based on the weather forecasting is very important in what is it to plant disease management. And this I give some examples that in tropical disease, tea blister blight, potato leaf blight, coffee leaf rust, and so on. We move to effect global warming on insect-borne diseases. The influence of environmental changes on plant vectors may be many variation. It depends on the symbiosis closeness between vector and pathogen. In this slide, I saw at least there are three grades of the closeness or symbiosis between vector and pathogen. First, persistence. Persistent means the obligate obligated in this case, in this what is it? It is create that the pathogen or transmitting must be in the vector's body, must be acquired by the vectors, because they must be replicate or reproduction in the body of vectors. Yeah, and usually need a latent period because the pathogen needs what it is time to reproduction and until the what it is certain abundance, and so the vector to be effective, to be infective for transmitting. And second, semi-persistent. Semi-persistent that the when vectors obtains pathogen, they directly can transmit the pathogen, but they cannot persist for a long time, usually not more than 1 day. And the last is non-persistent or non-obligate. Yeah, the pathogen is not the transmission not depend on the vectors, but the vectors can transmit the pathogen usually through the what they say the contaminants, contain the insect modes. So they cannot stand for a long time. Usually just few minutes or no longer than 1 hour. It is, I would say that the insect borne, most maybe the important disease may be transmitted by insects or called as the insect borne. That insect is poikiloterm organism. The poikiloterm organisms mean that the body's temperature determines by the environments they stay, they live in. So in this case, that we know that the temperature, the increased temperature will affect of the physiology of organism, and also maybe totally can accelerate the growth of adult insect, and also can speed up hatching insects eggs. Yeah. We go to fight that in this I would like to share about the interesting cases of plant disease epidemic suspected as an impact of global warming based on our experience and our research. First, on the first case that Fusarium wilt or basal rot of garlic in Tawangmangu, Karanganyar, Center Java, Indonesia, caused by Fusarium oxysporum formaspiris CP that emerged in 1999. This phenomena strongly suspected as the impact of global warming. Nah, 6 years when pathogen started attacking garlic in Tawangmangu, maybe just need 7 years to cover or to distribute it to all garlic fields in Tawangmangu. And I see, and it is make sense that the what is it, the case of basal rot of garlic Tawangmangu related the global warming, that can see the change of temperature, and now that in Tawangmangu, not so cool as a previous. And now the currents that maybe not so different with the in lowland, for instance, in Surakarta, altitude that at 100 meters above sea water level. In Tawangmangu, especially for Garrick field, in between the 1,000 to the 600 meter above sea water level. The temperature, the average of temperature reach 26. In lowlands, in Surakarta, 27. So it is logic that they occur on the case of the partial rot that so far to be important decision Tawangmangu is related to global warming. It also supported by the results of research the done by our students that the effect of temperature in bioculture, the pathogen is increased that the temperature until 35 is increased. And also maybe in the other research also that the increasing temperature can increase the disease and disease severity and disease incident. Disease incident mean the percentage of disease plant, and this without consider the grades of severity, but the disease severity is disease intensity that with consider the severity in the grade of severity. Anyway, continue the second case. Second case, epidemic molar disease in Brebes, Central Java, in Indonesia. Molar disease actually in the cause of molar disease same that the basal rot of garlic in Tawangmangu. That is Fusarium oxysporum forma specialis CP. Called molar disease because the characteristic symptom is twisting. Twisting. Molar in Japanese. The local farmer also calls anoles. Anoles, I think the name of a singer woman who is popular to her shaking ass and trailing. Because twisting or shaking. And molar disease is also called as a janda pirang. Janda pirang maybe the predicate that given by the farmers in a local farmer in Brebes years ago. Maybe if we searching in internet, maybe we can get the predicate. And that why call it janda pirang? Because gelatin yellow and then dry out. So the color, if we look from far side, looks, what is it? The albino or pirang. Pirang mean albino. And that time, the weather was very hot. Is based on the results of the farmer, our colleagues, research colleagues. They did monitor the temperature, especially at noon, can reach 40 to 50 Celsius degree. I think very hot for tropical. Yeah. And soil temperature between 27 to 35 Celsius degree. It, based on the previous slide, it's optimal for growth rate of pathogen. So it is strongly suspected that janda pirang disease is a complicated disease caused by Fusarium, Oxysporum formaceae predisposed by extreme weather, especially temperature, as impact of global warming. Because the Fusarium oxysporum cepae is a weak pathogen, so because the plant and was stressed by actually such temperature, so plant salads to be weak and to be susceptible to the infectious from Fusarium. Okay, for the last, for closing, that I will, what is it? I would like to, what is it? Maybe just for recommendation, mitigation through plant health management. I mean that it actually not just for that, maybe many other strategies can be developed. But in this occasion, I just emphasize four, what is it? Just emphasize four strategies. First, early warning system. Based weather forecasting station to determine, I think it is important to can proper planting sequence and proper planting time and proper plant time and also varieties. And also, and the first slide also, I explained later the epidemic disease. I think it is also important for predicting epidemic disease and the population of disease vectors. The second is develop several varieties. That first, that resistant to environmental stress, and second, resistant to infection disease, and resistant to disease vector space. And then the strategy, good culture practices such as use mulch to reduce evaporation, use of organic fertilizers to minimize the stress, because the organics fertilizers can increase soil water holding capacity, and so what is it, can increase the tolerance of plants to drought, and also increase soil fertility, so maybe can promote plant to, what is it, the root zone maybe will be wider. And then induce resistance biologically. Yeah, actually, I as a plant pathology and I feel in biological control maybe most interested in this. Many microorganisms have been reported that they have potential to or as inducers of plant resistance, both to the environmental stress and also to the infectious disease, such as plant growth promoting rhizobacteria, mycorrhiza, and so on. And last, water management. I think it's important, but for collecting rainwater with reservoirs to irrigate plants in dry season, and also effective irrigation such as drip irrigation system. Anyway, before I give back the time to the MC, I have a slogan. Plants healthy, human healthy. If plants are healthy, human will be healthy. Thank you very much. Again.
From the floor, he mentioned a very nice conclusion regarding our today's symposium, plant and health. Okay, do you have any comment, questions from the floor? Okay. So maybe you are very hungry. So please ask the comment, questions to him directly during lunchtime. Okay, thank you very much again, Professor Hadibiono. Thank you very much. Okay, so I would like to invite Professor Ken Hiramatsu to express our appreciation to all of the keynote speakers to present our souvenir. Please come to the stage, all of the keynote speakers. Please, Professor Udin, Professor Muraoka, Professor Hadiwiono. Okay, please. Okay, please take photo. Okay, one by one. Okay, thank you very much. Okay, so our keynote plenary session has already successfully concluded now. Okay, so I would like to inform the small housekeeping items from now. So we have to move the venue from here to the building of our graduate school from now. So we will provide you the lunch box there. So our student staff will guide you the venue. Okay, please move to the our buildings. So, but my English is not so good. So, Dr. Komaria will give you some talk in bahasa Indonesia.
Bahasa Indonesia. Dalam bahasa Indonesia, Bapak Ibu. Jadi ini adalah sesi terakhir kita di auditorium ini. Untuk kegiatan berikutnya adalah di gedung Yuksas di Graduate School. Nanti mohon mengikuti mahasiswa makan siang, kemudian sesi berikutnya dan ada ruang sholat juga. Mohon untuk mengikuti. Terima kasih.
全体の1階にいくつかそのパーティスパントリスト
Oke.
で
Please
ボーディングボーディングプレス
Oh iya, satu lagi ada poster di gedung Yuksas di lantai 1. Di gedung berikutnya ini akan ada poster-poster dari mahasiswa doktor. Mohon bantuannya untuk memilih, untuk vote poster yang terbaik, the best poster. So we also have another announcement. There will be some posters from our students at the first building of the graduate school. Please vote for the best poster. Thank you.
Okay, thank you very much. So our parallel session will be start from 1:45. Please come to the each room after taking lunch. And so as Dr. Komaria mentioned, we have a poster presentation by our student. That's the core time. I mean, the student will explain each posters tomorrow afternoon. So please pen your voting until you hear their explanation. Thank you.
Gifu University, the core hub for research, education and contribution to local society. we will connect them with various regions of the world. The aim of Gifu University is to commit high-quality research that is the foundation of education and to provide highly skilled professionals in today's changing society and environment. We aim to serve as an advanced research hub in its unique research fields in the life sciences, environmental studies, and manufacturing fields. We actively form partnerships with other universities to promote regular structured exchange of academic information and students. In conjunction with our partner university, Gifu University offers joint degree programs. We support our students to think globally and act locally. Also, we are rapidly improving the quality of its efforts to promote regional revitalization by collaborating with local governments, enterprises, and other universities. Our initiatives contributing local communities are highly esteemed by the Japanese government. We undertake not only internationalization rooted in the local community, but also globalization by providing the benefits of internationalization to the local community. Why would you choose Gifu University to study, research, recruit from, partnership with, or perhaps more? Because at Gifu University, we are committed to help you in both locally and globally becoming exceptional. Gifu University. Our university is located in the heart of Japan and has excellent accessibility to other major cities, as well as an easy access to international airports. The history of our university dates back to 1873. As the fourth oldest university in Japan, Gifu University is a unique and historic institution and has rapidly been developing since the 19th century. So far, more than 10,000 overseas students and researchers have studied from all over the world. We strive to be a university serving local communities. Our university consists of 6 faculties: Education, Regional Studies, Medicine, Engineering, Applied Biological Sciences, and Social System Management. Gifu University provides a perfect learning environment, surrounded by nature's beauty, offering an affordable lifestyle in a very safe city, where new beginnings meet endless possibilities. Gifu University. Redefine your possibilities.
The world faces a significant global challenge as the human population is projected to reach 9 billion by 2050. Food security ranks among the most urgent international issues. The COVID-19 pandemic has further strained health systems worldwide. Fossil fuels, predominant in electricity production, emit greenhouse gases that exacerbate climate change. The last decade has been the warmest ever recorded, leading to devastating climate disasters. It is necessary to accelerate the transition to an affordable, reliable, and sustainable energy system by investing in renewable energy and implementing environmentally friendly energy technologies. Universities are pivotal in advancing global welfare. Universitas Sebelas Maret, as a higher education institution, has become the common thread holding together all solutions for the 17 Sustainable Development Goals through its learning, research, and community service programs. Universitas Sebelas Maret was established on March 11, 1976, as one of the most outstanding universities in Indonesia. Universitas Sebelas Maret has built its vision and strategic plan on becoming an internationally excellent center of development in science, technology, and arts based on the noble values of national culture. Universitas Sebelas Maret is located in the city of Surakarta and is also known as Solo. Solo is a very comfortable city where Javanese culture and modern life blend. The Solo life, which upholds the value of harmony, has prepared Universitas Sebelas Maret graduates to be future leaders. To achieve the vision of Indonesian higher education, Universitas Sebelas Maret offers a variety of courses on a wide range of subjects conducted by 14 faculties, a vocational school, and a graduate school. With its adequate and appropriate learning infrastructure, Universitas Sebelas Maret offers a unique and engaging learning environment. It provides integrated IT facilities and information systems in a convenient academic atmosphere and green campus area. In addition to being a center of excellence, Universitas Sebelas Maret is home to students from all 38 provinces in Indonesia and 34 countries worldwide. This campus life creates a multicultural environment that promotes mutual understanding. Embracing diversity and respecting all cultures makes every student feel recognized and valued. Every year, Universitas Sebelas Maret deploys more than 1,000 students and more than 1,800 lecturers to the community service program, together with research activities from lecturers, to solve various problems in society. Regarding food issues, Universitas Sebelas Maret develops various plant varieties and climate and soil mapping with adequate laboratory facilities. To encourage the use of renewable energy, Universitas Sebelas Maret has a Center for Excellence in Lithium Battery Science and Technology and Electric Motorbike Innovation. Universitas Sebelas Maret implements UNS Green Campus governance through emission-free days, waste recycling programs, and dye-based solar panels to support sustainable environmental management. Universitas Sebelas Maret has been developing startup, business incubation, and entrepreneurship programs to eradicate poverty. In education, Universitas Sebelas Maret deploys around 1,800 students every year to carry out teaching programs in schools. And finally, to contribute to the health sector, Universitas Sebelas Maret has a nonprofit teaching hospital to serve the community. Active partnerships and strong collaborations have become inseparable parts of Universitas Sebelas Maret. Our international partnerships create ample opportunities for student and staff mobility in collaborative research and teaching activities. International collaboration helps to give a global perspective on learning to address global challenges while still functioning in a national environment based on potential and local wisdom. We gladly welcome you to explore and experience our program and enjoy our campus life, which depicts a blend of cultural power, professional life, and technological advancement. Universitas Sebelas Maret.